Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you study for a certain type of question that's going to be on your next test. And there are going to be some questions on there about deciding whether or not something is a function or not. Now, there's a couple different ways, there's a couple types of problems here. Problem type number one, sometimes they're about graphs, and I'll do a couple of them here. I'll do like one in red, one in green. Okay. To tell if a graph is a function or not, it has to pass the horizontal line test. So here's a horizontal line, and again, look at the red. Vertical line test to tell whether it's a function or not. So this passes the vertical line test. The red guy here is a function. Green guy, however, does not pass the vertical line test, so green is not a function. Some of the questions could look like that, graphical questions. Other types are questions about functions themselves, like maybe, one function, f equals 2x minus 1, and maybe g equals x squared or something like that. To tell whether these are functions or not, you just really have to know, is there any, like when I look at this, if I put an x in, how many y's am I going to get out? One or more. As long as you get exactly one out, it's a function. So this guy's a function, no problem at all. If I put any value for x into this, calculate a value, I'm going to get one value for g. This guy's a function, no problem at all. But something like this, x equals y squared. This one right now, notice that if y is 1, x could be 1. But if y is negative 1 squared, x would also equal 1. Here's a failure of the function test because you have the same element in a domain going to two different values in the range. So this would be a failure here, right? And notice this would not pass the vertical line test because it would go through, if I were to graph it, 1, 1, and 1, minus 1. So it would touch twice. The third type of problems of this nature are questions about sets of points, and there's a couple of these on your test. So here are a couple sets, and we're going to talk about them. I'm going to call this set 1 and set 2. So what this set here, this is a set of data points, and this 1, 3 means that f of 1 is equal to 3. 2, 5 means f of 2 is equal to 5. F of 3 is 1. F of 2 is 7, and so forth. You'll notice that each value of x here in this set goes to exactly one y value. There's no spot here where I've got a single x going to a y. So this guy right here is a function. Now the part that may look a little confusing here is these guys right here and here. So this function apparently maps 1 to 3, and it also maps 3 to 1. There's no problem with that. All right, this 1 is still going to exactly one x value. I don't look, or one y value. I look elsewhere. I don't see a 1 going to anything else. This 3 goes to exactly one value. I don't see 3 getting mapped elsewhere. This guy's a function, no problem. Let's take a look at set 2. So 2 gets mapped to 3, negative 1 gets mapped to 4, 3 gets mapped to 2, 1 gets mapped to 4. Now, this guy, let's see. Looks like that is a function as well too. There's just no problems with that. I'm going to look at a third set here, very similar to it, where 2 gets mapped to 3, negative 1 gets mapped to 4, 3 gets mapped to 2, 2 gets mapped to negative 5. Call this one set 3. This one does have a problem as you read these across here, because here we've got that f of 2 is 3, but here we've got that f of 2 is minus 5. Now we have two single x values, or one x value going to two different y values. That's a no-no. This is not a function. I don't see in your homework any practice of this stuff. We'll probably talk about it a little bit more on Tuesday. I just wanted to let you know, be aware now that there are some questions like that, all right? We'll talk about it Tuesday.